All right. So thank you everyone again for attending in person and virtually on Zoom. Today is the first kickoff meeting for the James Brook Watershed Coastal Flood Pathways Mitigation Design. I know it's kind of a mouthful, but it does mean a lot of important things for the areas that we will be discussing today. We'd like to thank CZM for funding this project. Obviously, it wouldn't be happening without them. And we'd like to thank Weston and Sampson and Woods Hole Group, Nasser, who some of you may remember from the last CZM round. But this project is doing a lot of great things. So thank you for taking the time to be present today.
Great. So I'm going to pick it up from there if that's okay. Can you all hear me okay?
Yes.
Great. All right. So this is just an agenda of what we'll talk about tonight. Appreciate you all being here. We'll just do a really quick introduction of the team and an overview of the project. We'll talk about the previous analysis and design. We'll talk about some of the latest updates that we've started with this project. And then we'll talk about next steps and how we would love to have you all involved as we go along this process. And then we'll have a little bit of Q&A and discussion at the end. So we'll kick it off with the introduction of the team. So we have our team from Cohasset, which is Brian, and he's online with us, Montana in person, and Cassandra. And then myself, I'm Robin Seidel. I'm with Weston and Sampson, the Climate Resiliency and Sustainability Team Leader, and I'm the project manager for this project. I have with me Emily, who's also on my team. She's a climate resiliency architect. And then you have Nasser in person. Nasser, you can wave and introduce yourself. If there's anything you want to say.
Yep.
And then Allie Gilmore, and she's actually in the attendees land, also on Skype or Zoom, wherever we're on now. Whatever year it's in. Yeah.
You're showing your age.
I know. So why this project? As some of you might know, we mentioned this is the next phase of a previous study which identified critical infrastructure, businesses, and homes which are vulnerable to sea level rise and coastal flooding. And so due to climate change, the impacts experienced this year in 2024, like you can see on that photo on the screen, we will basically continue to see this happening. It will increase in severity and frequency. So with this project, we are really looking to build upon the work from the previous phase and start to vet out some of the concepts to make them a reality and get to a point where they can actually be designed and constructed. This is the project area that we will be looking at. This is the James Brook watershed area. And so we wanted to start with getting to know everybody, and we know we have a lot of people in the room, which is great, and a couple people online. So we just want to know, show of hands, do you all live, work, or spend a significant amount of time in this project area? Yes. If yes, raise your hand. Great. That's what we kind of expected to see. So how often do you come? Like, and you guys can kind of yell it out in the room. Never, a few times a month. Do you live in this neighborhood every day?
Every day.
Every day. That's what we expected. This is the perfect audience for this conversation then. And what do you all do? Do you live in the area? Like, do you live here? Do you work here? Do you just spend a lot of time dining and shopping?
Yes.
Yes. I love it. Perfect answer.
Recreation.
Recreation. I love it. Great. So we just want to go over on the next slide a couple of components of this particular project, because it seems like few of you might be familiar with the previous project. So the way we're starting this, we're just really getting started right now. We are just getting off the ground with the site investigation where we're doing some surveying. So you might have seen some surveyors out and about in the past couple weeks. You'll see them out again in the next couple weeks. They're just finishing up collecting all the information that they need to get so that we can have an accurate site plan of existing conditions. And then we've already gone out and done some wetlands delineation. Nasser is going to talk a little bit more about that and show you what we found. And then following that, we will be doing an initial characterization of the site where we'll begin investigating the existing conditions through this lens of the previously proposed and prioritized solutions. And then finally, I'll just talk a little bit about engagement. We will be interacting with hopefully you all throughout this project, and we'll talk a little bit about the end about ways to be involved in this. And what we're hoping to get to at the end is design plans and renderings that really show what this space could feel like should we put flood protection in this area so that everyone feels comfortable moving forward. This is our project timeline. As we mentioned, we just kicked this project off in January, and we'll be working from now until the end of June. Today is our first public meeting, so we're excited to have all of you join us and ask all your questions. We'll be doing a visioning workshop or in early spring. So that's when we're really going to start to get some more ideas together. And then hopefully we'll end this all with a visioning site walk where we can talk about all the work we've done together and what it might look like and what it might feel like together. And now I'm going to toss it over to Nasser, who's in the room with you, to talk about the previous phase of the work.
Thank you. So Robin already introduced kind of the area we're focused on here. It's really like the lower part of the James Brook watershed. Next slide, please. In the previous phase of this analysis, we looked at the latest available information on coastal flood risk. So, what's the likelihood in any given year that different parts of the watershed would experience coastal flooding? And so what you're seeing here is the present day. The key on the top right is sort of showing what each of these different colors means. But this is showing you the chance in any given year that we'll see flooding. So the green area, the light green area, so the two green areas together, let's say, represents like a 1% annual chance of coastal flooding. That's what you might hear called a 100-year storm. But we don't like to say 100 years because it doesn't mean it's going to happen only once in every 100 years. It means every given year you have a 1% chance. So as you can see in present time, the flood risk is pretty centered around the marsh area and probably people's backyards, a small portion of the roadway here. Again, really keeping in mind like our focus for the previous phase and for this phase was really on this area outlined, which is part of the James Brook watershed. I know there's a lot of existing flood risk on Marginal and on other parts of Border Street, probably also on Black Horse Lane. Those are not the core focus of this area, right? So we're not, through this project, we're not going to be designing solutions necessarily for, well, we're not focused on designing solutions for some of these other areas at risk. There are other parts of town that are also at risk from coastal flooding. And they'll need to be kind of, the town will need to continue looking at these issues in different areas over time. I did want to point out just that there is underground infrastructure that connects the marsh areas downstream to other wetlands further upstream. Those are not sort of integrated into the model that produced these results. So there is additional flood risk upstream that's not totally documented here. Because water can flow through those pipes, those culverts, et cetera, and go further than it could if it was just flowing over. Next slide, please. You can see how that green area that we're talking about, that 1% annual chance, expands pretty significantly in the 2030 time horizon. This is based on a high amount of sea level rise that we're currently tracking a little bit below the rate that is included in these maps. So it could be 2030, maybe it's more like 2040 or even 2050. But if things are bad and continue to get worse, which the news is often telling us is the case, then this could happen as soon as 2030. You can see here now that there are sort of significant parts of Elm Street, all the way past South Main Street, and along Summer Street that are also vulnerable in this scenario. If we go one more, 2050, you can see that you can see that the upper parts of the watershed start to be impacted again from overland flow. Doesn't mean that couldn't happen sooner, like going through those pipes. Cohasset Village. And then I guess the big takeaway is what changed in color right here in the center, right? So the really dark blue and the next shade are the 150% chance. So it's like a 1 year or 2 year recurrence. So really frequent flooding in the 2050 timeframe. Again, if we're following a high sea level rise curve. And so this is when things start to get like unbearable, right? You start to have this frequency of flooding that's sort of beyond where you can just easily, go about your day and recover from when it happens fairly rarely. And then moving on to 2070. Actually, do we not show 20? Okay, so this is a different kind of map. This shows the depth of flooding, and this is only focused on that big 1% chance event. So that big 100-year storm event in 2050 with high sea level rise. And you can see that there's pretty deep water in parts of the watershed. So the greens here are between 2 feet and 3 feet. So the different kind of shades of green that you kind of see here, 2 to 3 feet of flooding. So as there's more water, it can move faster. It can also carry waves, and it starts to have a much more damaging impact on infrastructure like roadways and the wastewater treatment plant, which sits there, I should have pointed out, in Jacobs Meadow. And that's kind of, this is the scale of the scenario that we're focusing on for this first phase. Can we get to the level that we can protect from this scenario from happening in a way that protects the critical infrastructure? That's like the primary focus, is the critical public infrastructure. That includes the major roadways, which are of course used by public safety to get in and out of areas, that are also access for affordable housing and for vulnerable populations. There's economic concerns here as well. There's private property concerns here as well. The wastewater treatment plant is another major focus. So to adapt the wastewater treatment plant only, right, just to solve that one problem is a fairly expensive endeavor. And all you get at the end of the day is a protected wastewater treatment plant. So the focus of this project and sort of the concepts that we're trying to advance is, can we get something that's better than that, that provides much broader benefit, including all the other important critical infrastructure, but also I won't call it a side benefit because it means a lot to a lot of people, but also can protect property, businesses, homes, etc.
How deep is the blue?
If actually, I forgot, if you click again, it shows you a little person scale. So so the darkest blue is above 5 feet. And I'm sorry, it doesn't mean that it's 10 feet, but it's above 5 feet, which is enough to make you.
Black is 10 feet. There are a few black spots.
That's right. Yep.
What is the expected water level rise by 2050 that this is modeled to represent?
So it's 2.4 feet of sea level rise, which is, again, it's on the high end of projections. It was intentionally chosen to be on the high end of projections because if it's too aggressive, right? If sea level rise doesn't rise that fast, we still expect to see 2.4 feet of sea level rise, but it may not happen until 20 years later, right? So under an intermediate sea level rise scenario, you'll get about 2.4 feet, but it'll be in 2070. If it's a high scenario, that happens in 2050. So we're kind of covering for a range of scenarios. And if we design to this level today, maybe it gets us this level of protection up to 2050, but maybe if sea level rise doesn't rise so fast, it gives us actual protection until 2070. Okay, that's the kind of way we're thinking about it. Next slide, please. And just to kind of reemphasize what I mentioned previously about critical infrastructure in the previous phase, we examined what would be impacted at different kind of probability levels. The stuff that's in the red would be flooding more frequently, more likely to flood in any given year. The stuff in the yellow in more rare events like that 1% chance event. And you can see all the roadways, you can see the commuter rail line, the treatment plant and other wastewater infrastructure is also impacted in the scenario. Where are we? We're up here somewhere up here. Maybe we're okay, maybe we're not so okay. The post office is shown here, Red Lion Inn, various other the church and some of the other community assets are shown here. Oh yeah, and let's pick up them all there a little bit. Next slide, please. So as part of sort of like the last step in the last phase, in the previous phase of this project, we were looking at what are some different options for increasing the resiliency to reduce the risk of flooding in this study area, in the lower James Brook watershed area. And we looked at roughly three different alternatives. All three of them involve creating some sort of flood barrier right on the Cohasset Cove waterfront, because that's one place where water comes in. Water is also kind of coming in around here, sort of north of Black Horse Lane, and then right at the intersection with South Main Street. And so one of the options was to really follow the roadway, which is a public, right of way. The town owns the infrastructure, and align with that. And what would be protected in that scenario is everything that's in yellow. Jumping ahead, this is the scenario this is the strategy that we are advancing through this project. We also looked at other alternatives, one that would follow Westgate Lane, and then a different kind of version of that would follow Westgate Lane and Black Horse Road. And then we looked at sort of I'll call it a wilder scenario where we looked at kind of, well, what if we could construct some kind of surge gate or large gate structure at the mouth of the river, and we wanted to know, would flooding come in the back door from Scituate or not? And so what would be protected in that scenario is shown in the darker blue. So plus this, plus this. So they're kind of like at three different scales. This one right here, the biggest one was, we estimate it to be extremely expensive, like orders of magnitude more expensive than either of the other two alternatives. It does have the most benefits, of course, like protects the most number of roads, the most number of houses, etc. But it is also very susceptible to potential failure on the other end. So in this scenario, in the 2050, 1% storm event that we modeled, water wasn't high enough to get over the berm that's along the beach in Scituate. But that berm is subject to potential erosion. And is it going to be there in the same shape, 30 years from now? We don't know, right? So there's a lot of uncertainty built into that, and what it would mean, not to say the least about trying to permit something like this with the environmental regulations. There's a lot of concern that, constraining all this watershed would have negative impacts on water quality, on marsh habitat, on aquatic life. And so all those things together would make it really challenging, really time-intensive process to even, put that forward. And even then, it may not be allowed. With this other alternative with Westgate Lane and looking at Black Horse Lane, there was a lot of reliance on private property to implement those. All it would take would be for a private property owner to say no or back out, or, any of those types of things that can happen. And if the town wanted to, exercise eminent domain, there would be questions about, oh, is there another alternative that wouldn't require eminent domain, which there is, right? And of course, no one wants to take people's property. So it's okay if I speak for the town and say that? Okay. So where we landed was looking at the alternatives that align with this public roadway infrastructure. And it is sort of in the reasonable cost. Well, we did a high level first conceptual level cost estimate of that. I'm going to guess that these numbers go up as we delve into the design more detailed. We didn't include utility costs, like the cost of adjusting utilities that are buried in the road, you know, for a higher road, for example. And next slide, please. So skipping one forward. So the alignment really involves interventions in two places, and they're to block those pathways that water wants to come into. Next slide. There's sort of two different scenarios. One is a vertical barrier, which is kind of like, well, oh, okay, we could raise this, put up a flood wall or a seawall, you know, a high seawall, et cetera. That's one strategy. And another one is to raise the roadway infrastructure, and then the roadway serves as a flood barrier, but you don't have some of the negative externalities in terms of like impacting views or disconnecting people from the waterfront. Raising the road is not like an easy task. It's not just that we can just, you know, raise it up. It involves a lot of engineering. There's a lot of properties that have driveways that connect to those roadways, storefronts, et cetera. So all those things are what we're going to be looking at as we move this project forward. The next slide. And again. So in the Elm Street and Border Street area, the area that we're looking at raising essentially through a raised roadway, it starts in sort of the Margin Street area and then wraps around. There'd be an interconnection with Elm Street here, of course. And there's existing high ground here. And many of these properties are actually where the buildings are set up pretty high. But the roadway along border is pretty low. And so a portion of that roadway would be raised as part of this. And I mentioned previously that other parts that are outside these areas would not. One of the challenges with raising something like raising margin is that water can kind of come in through the backside, right? There's like a big interconnected floodplain in that area, which is hard to adapt. And on this side, we have a lot of waterfront property owners, some of whom just recently made investments. And so the timing to rejigger, you know, the elevation of the road versus their parking lots and their, you know, businesses, et cetera, is fairly complicated as well. And then I just want to mention that the outfall, there's a tide gate structure at the end of the culvert that you can see here that empties all of the James Brook watershed into the Cohasset Cove. And that structure has tide gates on it, but water could go over the tops of that structure. And so part of this strategy involves raising the top of that structure so that it's sort of like a little chimney so that it's higher than the water surface, so that water doesn't go over that and then come out on the other side of our barrier. Next slide, please. And this is showing the conceptual strategy. Previously, sort of the existing road is here, talking about raising the road here. And then at the, I'm not sure if it's this slide or the next, go to the next slide. On the waterfront, raising the tide gate structure, the height of it. Next slide. As we turn and go up Border Street, or as we go south, I guess, to raise the road, you need to rebuild a portion of the seawall. Could be concrete as it's shown here. We're gonna, Collins Engineers, waterfront engineers, they will evaluate some different alternatives. It could be rebuilding existing the stone wall that's there. But the idea is basically to provide a retaining structure that's higher, that allows the road to be raised as well. And it would tie into existing driveways on the land side. Next slide.
Can I ask one question?
Sure.
What's the height of the proposed road there? Like the depth of that? It's hard to read that.
So the center line of the road looks to be like maybe 2 to 3 feet, maybe 2 to 3 feet higher than it is today. And then the sidewalk will be an additional, I don't know, half a foot, and then a little bit more for the seawall. Any other questions? We'll move on. And then, so along Summer Street, we have kind of two elements. One, this is kind of like the low point. This is probably assuming that January when we had the really high water levels, I'm guessing that water came over Black Horse Lane and probably here as well. What we are constrained with here is a couple different things. One is there are wetlands that are on this side of the roadway. So we can't really, when you raise a road, you typically need to go out a bit more unless you put some sort of retaining structure. And then on the land side, the buildings are actually very close to the roadway. So there's not a lot of space in front yards or driveways to kind of make the transition from a higher roadway to the front yards of properties. And so what we have here is actually a vertical structure. And then for this section here, we are able to accommodate within, we think, but based on this conceptual level analysis, that there's enough space there to be able to raise the road, a modest amount, not needed to be raised too much higher, which you'll see in the next slide. Next. So this is a vertical barrier. So it's shown here as like a concrete flood wall. Again, there's various different alternatives that we can look at to design both kind of what the structure is made of, but also how it looks. Next slide. And then for the portion that's a raised road, it is a relatively modest raise. In this section, I think it's maximum 2 feet. And there's enough space to kind of grade back down, we think, based on this conceptual analysis, to the existing ground elevations. Next slide. And this is even more modest by South Main Street because it's already higher. Next. So that's where we're starting from. That's what was completed around the end of June last year. And we're now, as Robin mentioned, really diving deep into what's on the ground right now, the existing conditions, and a lot of that's topographic, right? Like how high is everything relative to each other, so that we can find out where are the pain points when we try to raise a road to get back down to grade, and how close are buildings, et cetera, where are the front steps, all those things that need to be considered. So we have site survey ongoing. To identify locations of utilities, things like parking, the seawalls, adjacent properties, and other site conditions. Next slide. We've already completed a delineation of the existing wetlands in the area. It's, of course, when you're working in a coastal environment, one of the big challenges is that you may be, if you want to do something, you want to build something new, you may be having a negative impact on natural resources that are protected under state law and regulation, including and local regulations. So the first thing to do is to know what's there, what's out there in the environment. And in this area particularly, where we're talking about potentially raising the seawall, we need to be cognizant of, there's salt marsh on the other side, that's what you can see in green. So there's kind of fringe salt marsh. There's also some areas that are called just coastal bank that are more natural, kind of sloping landforms, which when storms interact with those areas, they can actually release sediment, like they can be eroded a little bit, but maybe in a good way. And that sediment, goes to, downstream areas like coastal beach, which is shown here in the light tan color. So that's kind of what we see in this area. And then there's also sort of other kinds of coastal banks. So any seawall that's out there, or the revetments, like those rock faces, those are also coastal banks, but they're not sediment sources. So the way that they're treated in the regulations are a little bit different. It's less restrictive, I would say. And then we also have another wetland type, which is called rocky intertidal shore. And this is things like big boulders that are covered with algae, right? Like you look at it and you're like, oh, it's just some algae in the water or something, but that's actually important habitat for a lot of different kinds of marine species, like different fish, especially when they're young, go in there, they feed smaller, invertebrates and things like that, kind of hang out in there. And so it's also protected under the wetlands regulations. So, you know, this is gonna be a challenging thing for us to navigate, the salt marsh, particularly being so close to where the existing seawall is, how we're gonna investigate like construction methods that will minimize the potential impact of the salt marsh. And we may also have opportunities to, if we do have some impacts, for example, that we can't avoid, we may also look for opportunities to improve the existing resources that are there. And if you go out there and we have some photos, you know, there are portions of this marsh that have kind of caved off because they've been undermined from underneath. There's been like erosion underneath the marsh platform, like the peat. And so that piece of salt marsh is kind of just waiting to be slowly eaten up by the sea. So, you know, maybe restoring that could provide an offset for some small impacts that we may be unable to avoid. Next slide. So along, this is, I think the aerial here is a little bit offset, so you can kind of see like on the yellow line here, but essentially what we find here, this is along Summer Street, is that we have some salt marsh. Around that salt marsh is a coastal bank that is more natural, so there's not seawalls and things like that, but you know, it's these vegetated, often surfaces that kind of rise out of the salt marsh. And then we have some areas they're called bordering vegetated wetlands. So there's more vegetation of specific kind of types that are more wetland species, right? So you see them in more wet environments. So we've identified kind of the boundaries of these. What's not really visible, because I think the aerial here is a little bit mismatched with the imagery, is that where we were looking at aligning that flood wall eventually along this section here, which is what we were most concerned about, is that going to have a negative impact on these salt marsh areas, is not within the footprint of some of these existing resource areas. So we're feeling positive about this in the sense that we think we can avoid having negative impacts on those areas. But as part of this project, we will be looking at kind of at the end of it, once we have a design, you know, what kinds of impacts would this project have if it's carried forward into the next phase, right? If we go looking for money to take it the next step and get it really ready for construction, or even get it constructed, there's a mid-step in there that's permitting, right? You have to get approval from the regulatory agencies. And so this information will be really useful once we get to that phase. What we're going to be looking at the end of this phase of the project is really getting the landscape. Okay, so if this is what the project looks like, these are the kinds of impacts, this is how much it would cost, how much time it would take to permit this project. These are the different kinds of permits that we will need to get. Next slide.
Now, sir,
Yes.
quick question, are all the wetlands private? So, and does that matter at all, whether there's any publicly owned land that would be in the category of resource area?
So once we have the survey, like once we actually finish the survey, we'll be able to better identify kind of, I don't think the property line survey is specifically included here, but they will be on the same horizontal. We'll be able to basically tell what portion is on private versus what's on public. I would say that probably for the Cohasset Cove area, that's going to be largely either it could be town, it's within the town jurisdiction. It's probably not within property lines for the most part. Like a lot of this stuff is going to be potentially what would be considered, I guess, state land, right? In some way. Yeah, Jason, I don't know, how does, what's
It would be Commonwealth Islands, or if it would be
municipal? Yeah, maybe it may be town, maybe considered town owned in that case. But I would say that on Summer Street, a lot of that's in private, almost all of it's in private. So there may be some portion of like the coastal bank area, it's the orange here, or maybe even a little slice of the bordering vegetated wetlands that are within the roadway right of way. But almost all of what you see back here is all private.
Same with James.
You mean on the inside? Like the inside the Jacobs Meadow, like that marsh? Yeah, there you have a big mix of different property, right? So like a lot of people's property lines in Jacobs Meadow go like down to the center line of the channel or something like that. So there's like these really long strips of property that are basically in marsh that you couldn't go and get a permit to build a house in. there are also like overlapping, like, you know, the town has some easements for wastewater infrastructure that's back there to maintain that infrastructure. There's some conservation easements that the town owns that, you know, they've one way or another gotten from property owners, so they have an interest in some of those pieces of land. But because we're not proposing to do anything physically on the Jacobs Meadow side of the roadway, it's less consequential, so we didn't map those out. We were really focused on where we thought there could be impacts from this project. Next slide. Is it back to you, Robin?
It's back to me. So I'll just note that another project is happening while this project is happening, and it is also being funded by CZM. It is a wastewater treatment plant critical infrastructure grant, and that work is really being performed by Woodard and Curran. And essentially this project, I'll do my best to kind of describe it, and if you have more questions about it, Brian is on the line, might be able to answer those. But the purpose of this is to really reduce the inflow during heavy precipitation events, which will reduce the risk of catastrophic failure of the critical wastewater systems. And so an anecdote to that is that on January 9th and 10th, Cohasset had about 3 inches of rain overnight, which is a lot of rain in a short amount of time. And the plant processed a significant amount of flow, which required the employees to do emergency measures to treat the wastewater and operate the facility. So the purpose of this project is really to prevent that from happening again. And then we'll just close. We're getting to the end of our slides here.
If I add something to that, Robin?
Oh yeah, please, yes.
Yeah, so it's just so it's both it's really to prevent sort of that saltwater inflow from a big coastal storm event. So, you know, a lot of the manholes that are on these pipes, like there's like basically 3 or 4 pipes that just all come into the plant from, you know, different directions. That's where, you know, if you trace those back, they go to all these people's houses, right? But those ones that are right in Jacobs Meadow are really low and they're very old, and the pipes are made out of clay, right? These are old pipes. And so in big rainstorm events, a lot of water starts leaking through these systems and even comes in maybe through the manholes themselves. But in a big coastal storm event, that water would be coming in from water that's sitting over the manholes, sitting over land, and really pushing salt water, which is different from, you know, fresh water into the plant. And if a huge amount of salt water goes into the plant, as it has done in other communities, like in Hull, where some of the treatment for the town of Cohasset goes, it's very catastrophic for especially the biological processes that are in there to break down all of our waste, but also can damage equipment and things like that. So that's a big portion of it, is reducing that kind of inflow from that significant event, and also to raise some of the lowest lying like electrical infrastructure at the plant, that if that piece of electrical equipment gets inundated with water, the whole plant would have to, you know, basically shut down. So it's going to be raising that up, you know, to a very high level so that the plant can continue to operate, or at least get back up and running very quickly.
How high is the treatment plant have, or the equipment need to be raised?
So I'll take that one. So
Sure.
The equipment, you know, the equipment's at different elevations throughout the plant, and the equipment that we initially looked at here was the generator and the automatic transfer switch and the transformer that feeds the entire plant. As it turns out, the generator, when you go in and look at it, it's actually pretty elevated. So we went to the next lowest equipment, which was inside the plant, and it's sitting on the floor inside the plant. So those pieces of equipment are going to be elevated about, well, above the floodplain projected in 2030 and 2050. So about over 2.5 feet. They're still going through that design. And then the transformer and the automatic transfer switch will be elevated, which is, you know, at the head of the driveway there. Again, above that floodplain that's projected.
The reason these two things were structured together is that like, this is like immediate stuff that could happen now, that could be damaged now and have very significant consequences. And, but designing a solution for the treatment plant just on the site of the treatment plant, not very effective, you know, considering like, well, all the houses it serves are underwater, right? So the idea was to pair these two things, one looking at more long-term solutions, more regional solutions with something very site-specific and critical.
All right.
And thank you to CCM supporting both of them.
So now we'll just really quickly cover next steps and how to get involved in this. If you are in person, please, if you have not signed the sign-in sheet and given your information, we would really love for you to do that so we can keep in touch about this process. We'll be doing a visioning workshop, as we mentioned. We'll be sort of talking about some of these ideas and trying to really figure out the details of them. And like I said, then the site walk, which we hope to walk with all of you and talk about what will happen in the future. We just have a couple more questions. So if I guess this is sort of a hard poll to do virtually, but think about the best way for us to contact you and your neighbors, because we want to get everyone involved in this. I heard someone in the room early on saying that they wanted to get everybody involved in this. I think it's really great. So let's think about ways, and please share them with Montana in the room, or if you have ideas and you're joining us virtually, please put them in the Q&A and we'll take that in so that we can better get the word out about this project and get input on this. And that's it. We'll kind of leave it open for questions. I will be watching the Q&A online, and Nasser, if you wouldn't mind starting to answer if there are any questions in person.
Sure. Yeah, so this is early in the process. We haven't drawn anything new on the paper yet. So, you know, understanding specific concerns or questions or desires, you know, from you all would help us, you know, start off on the right foot. But yeah, open to any questions or comments you might have.
Just in terms of the communication, I would strongly recommend all of the above. I've been noticing that it's really, I think this town struggles to disseminate information widely enough so people attend meetings like this and meetings at the night. At least about a dozen people out of 8,000 residents. And I think since our newspaper went away, that's been problematic. Social media works, but I think we're going to do mailers as well.
Mailers, yeah.
I'm Tom Bell, Conservation Commission, I'm a geologist. As a geologist, I view topography as temporary, at least on a geological scale. But one of the things that is an assumption in this exercise is that these elevations will remain stable. And given at least under current conditions, were there to be a large coastal storm, the storm tide pathways would be subject to erosion. So the initial assessment of what could flood and how quickly it could flood seems to be important. So for example, at the Cove, I guess it's margin or border street there would be overtopped, it would, my own opinion would be that the landward side could quickly erode and excavate a new opening to James Brook. And under those circumstances, it seems to me that the impact would be substantially greater. That's the first thing. The second thing is, if we're getting 6 or 8 inches of rain in the James Brook watershed, you've got the collision of fresh water running down the watershed with storm surge running up the watershed. And so are you envisioning how those two things might interact?
Okay, I'll take those first and second. So I guess on just to help frame kind of how we're thinking about like the edges, where does this?
You might turn to a slide that shows that,
Sure.
geography.
Yeah. Slide back to.
Yeah, that's probably,
That's fine.
that probably works.
Yeah, that's fine.
Yeah.
So, so like in terms of the topography, there's pretty high land right here, which is kind of where we're thinking about the crest of our, elevated roadway structure, and that turns out to be feasible would kind of tie into. And so, I don't know that I chased it, much further back way, but we did look at the storm pathways data. So I don't know that there's a way for it to really go around it, but maybe along the edge, So I don't know.
Probably not. What I would in fact envision would be that right at the tide gate, if you have a spillover there, the landward side could be subject to a at least initially a pretty, a couple of feet of drop in elevation, and erosion of right where the sidewalk is there, erosion back towards the cove could
So you're saying.
could result,
this
yes,
section
could
here,
result in
there's a failure of this-
there all the way down. See the sidewalk where your hand was there? There's a sidewalk, no, that crosses the street into James Brook. Yeah, right there.
Okay.
That if that were start to erode, the channel could be developed. And it could be far worse than just assuming that everything's gonna hold.
Yeah,
Just make
So-
a brief comment on that.
Could I finish, Brian?
Yeah.
I
Sorry.
know that you guys are doing some test borings in that region, and so I'm sure you're gonna find out whether you've got bedrock there that would restrict that type of erosion, or whether in fact there's some historic fill, or perhaps some glacial fill there that might be subject to erosion. So we're gonna have an answer to that, or at least more information about that in the next couple of weeks, right, as you guys finish your boring exploration there.
yeah, the boring that we're taking closest is somewhere in this vicinity over here. So a little bit offset from specifically where you're talking about, but yeah, I think Brian, go ahead.
No, I was just gonna say with respect to Tom's comment, I understand that, you're saying that the sidewalk that flow back through the culvert could then erode the other side, but that culvert system actually goes beyond that legion. It's a three-sided precast, kind of a bell and spigot. So that precast section goes all the way past. It's a little bit hard to see, but kind of where you see the dotted, look like stones. It's a gabion wall on the, the lower left behind the legion. So it's pretty well protected. Yeah, all the way back to about there. And then, it could erode from there, but again, it would be, it'd be further away from the roadway.
I think
And
the
that-
concern about sort of a raised road eroding, like a levee could erode, right? Is something that we'll be considering in terms of like the structural design of the improvements to limit the risk of that.
I think the same issue might be examined at your test borings on Summer Street as well.
Right.
I just reviewed what you guys had proposed, and I thought sites you've chosen to test, be interesting again to see what the subsurface looks like there, whether it is prone to erosion or whether there's in fact bedrock there that would restrict that, and what the depth of bedrock is. But I think that if the edge of the road, for example, started to erode, it could be a very rapid sort of event that could widen an opening. I mean, we see this in storms all over Massachusetts, right? Where new inlets open up from time to time under
Sure.
severe storms. And my question is it possible here? Could we open a larger inlet say to James Brook or across the to Summer Street from the Gulf.
Yeah, I mean, I don't know,
And
I don't know
really the
yet,
question is,
but it's a good
If we
question.
don't do anything.
I was gonna say that also.
If we don't do anything,
If we don't, then the risk would be probably higher
Yeah.
that would happen. So, yeah, but well taken, that's an important risk to consider. And on the other question, we are, we will be analyzing the impact of a combined event. So an extreme rainstorm at the same time as or timed up, let's say, synced up with very high coastal storm flooding to see whether this would
And there is-
exacerbate
and
that.
if there is this collision. What do you do about that? You've got a massive amount of fresh water coming down James Brook. At the same time, you have a storm surge. Obviously, you're not going to be able to pump that water back over the hump at Veterans Park. So how do you deal with a situation like that?
Yeah, I would just say, I mean, you're exactly right, Tom, and that's what happened on January 9th and 10th. We had that 3 inches of rain in about 6 or 7 hours. And it was between about midnight and 6 a.m., followed by a 9 a.m. high tide that was a storm surge of, I want to say, about 2 feet. And that water can't go anywhere until the low tide lets it out. And when you have a storm surge, you know, that low tide comes later on. So the water just impounds there until it lets it out. And there is nothing you can do there. It's just a matter of time. You know, it's gravity flow.
So what will your analysis include the volume of water and the amount of pumping that might be necessary to clear the fresh water from James Brook back into the ocean?
So there's no pumping.
It's not in the scope of this
If
grant,
you had to pump,
but
and how long would what would the residence time of that flood be? Even when the tide went out, flowing through that small culvert, it could take quite a while perhaps for that flooding to be alleviated. So would pumps be it really comes down to, would pumps be a wise idea to be installed there?
yeah,
So
so
that under those circumstances, you would have at least some capacity to move that. Gravity will do some of it, of course, but if you've got a small orifice like the culvert here, it could take a while for a significant freshwater flood to be moved out, even at low tide.
Yeah, I don't think any pumps would replicate the size of our tide gate. The tide gate is a 10 foot by 6 foot opening, and then an additional 4 foot diameter flap check valve. You know, you're talking millions of gallons per minute, and pump sizes of that, you know, that capacity are just, you know, you're talking about New Orleans levees. It's something way beyond. So the capacity of the tide gate to release water is as big as the culvert that goes underneath, you know, the street and into that channel there.
And you've got what, 6 hours with each tidal phase to move that water, and then you have to close that tide gate, assuming it's operational still, and wait another 6 hours or whatever to again open it up to release the floodgate. So it seems like the timing of a serious freshwater flood on the James Brook side would need to be modeled to some extent to know whether, you know, how long it would take to remove that freshwater flood based on the tides and the size of the culvert here. I'm not saying it's inadequate. I'm just wondering if,
yeah,
you know, if this has been a consideration. Are you going to model removal of that flood water
Yeah.
by gravity?
I would say,
Through
so
this
yeah, point one is that it's not part of this current grant scope, but we do have another ongoing slow moving project with the town that worked to develop sort of the model, 2-dimensional model of the watershed where we intend to run that scenario or several scenarios just with this improvement. We haven't talked about, like, we haven't anticipated things like pumps. I know that part of the flood control master plan that was developed like 2006, 9, somewhere in that frame, did look at pumping infrastructure as well as upstream detention and other kinds of landscape improvements that could be made to slow the movement of water down the watershed to reduce kind of how much discharge comes at once that needs to get through this large but small opening. So, there have been studies of other possibilities to help mitigate that issue. And I know Jason wanted to offer a comment as well.
Yeah, sir, thank you. That culvert and tide gate was reconstructed in 2011. And at that time, it was significantly upsized from the cross-sectional area that had been existing prior to that. And it was sized with the intention that it would be able to evacuate flood condition within Jacobs Meadow in a single turn of the tide. So that was something that was considered very good design of that. And there is an operational protocol, Brian, correct me if I'm wrong, for the tide gate management plan that calls for closing the tide gate earlier on an incoming tide to preserve as much storage volume in the marsh as possible. So a number of these things have already been considered and have been implemented. Great.
Yeah, that's right, Jason. So there's two modes. There's a normal mode that allows tidal flushing with the gate, and then when a storm is coming, when we anticipate a storm or a nor'easter coming, a day or two before, we put it in storm mode, which only allows outflow. So it basically drains the meadow as much as possible prior to, so you have some reserve storage in the channel and in the salt marsh, for that storm flow that comes down the watershed, the fresh water.
I'll just
Other
jump
questions?
in here. We have a few questions online. And the first question we have is from George, which says, which is the bigger risk, sea level rise or extreme storms? And do the proposed solutions potentially address both risks? Nasser, do you want to answer that one?
It's hard to say. I guess the historic experience is, I don't know, I guess Brian or folks in this room, historically, which one has been causing the most problem? Is it more the extreme rainfall when it's synced up with high tides, for example? Is that kind of like the scenario that?
Yeah, I mean, I think to the question, I think, this design is basically preventing the storm surge coming in from the ocean, but really the rainfall can't leave until that low tide lets it out, or until the elevation of the ocean is lower than the elevation of the meadow. And there's, when you have extreme rain events with a large amount of precipitation in a short amount of time, there's no way to get rid of the water except by gravity, when the tide lets it out. I know that's.
So, but I would say, like, when we look at those 2050 maps and the likelihood of flooding in the long run, it's, the sea level rise piece here and the storm surge piece is extremely consequential for this area. So maybe the current experience is one thing, but as the risk of sea level rise increases, as the effect of sea level rise on coastal flooding increases the frequency of flooding and how high it gets, it will become more of a problem. And I think we're seeing that already as someone who lives on a coastal area that gets frequently impacted.
Salt water is more of makes more damage than fresh water. Like if you have freshwater flood and it goes away, you haven't killed all your plants and you haven't gotten salt water on your plaster and all that.
Definitely.
We have a couple more online questions. The next question is, will you be addressing the floodgate itself, as this seems to be an issue for Summer Street and Elm, when in storms, the gate has gotten stuck flooding the area.
I don't know if Brian can.
So is
address-
that, I think that's a question about the tide gate.
Yeah.
Talking about the Jacobs Meadow tide gate. So there have been incidents in the past, I would say probably 3 incidents in the past 3 years. They've been addressed. Again, it's a mechanical system. It's got a backup generator that was installed 2 years ago for power. That generator is elevated above the floodplain as it is now. I think if we go through the analysis where we're gonna raise, either seawalls or streets, and the structure around the tide gate will probably elevate, the control system for the tide gate and that generator again. But right now it's functioning as it's designed to function.
Yeah, the only changes that we're envisioning as part of this design process is really, as I mentioned before, that the tide gate structure, raising the rim of that, basically raising it like a chimney, like I said, raising the chimney up so that water doesn't flow over the top of that structure and then pop out the other side of the roadway.
And then we have one last question, which is if the road is raised, would that cause more flooding to homes as the water would run off and down?
That's a great question. It's one of the things that whenever you're raising a road, you have to think about the drainage systems, right, that go along with it. And so, like I mentioned, those costs, that we had estimated are likely to go up because they didn't include those utilities. Stormwater utilities are part of that. So as part of the design, we will be looking at how does that stormwater get managed. I would say if you were to do it without thinking about that, without designing for that, it could have those impacts. It could, instead of water draining from someone's private property to the road, it could go the opposite direction. So, the design process will aim to minimize those types of impacts.
That's all I have for online questions. We can pass it back to the room if there are more.
Yeah, fine.
So you made reference a couple times to design responses needing to have a relationship or specific response to existing environmental conditions, salt marshes, coastal banks, all that stuff. And you've done a good job of modeling sea level rise as it relates to flooding. Are you going to model the impact of sea level rise and all these natural resources that are going to influence how design responses are supposed to be met when, for instance, the marshes there along Margin Street, they'll be gone in a few years. That bank goes all the time, it's falling in. So we have these kind of rules that the state is going to impose on us, or the feds, that we have to respond to for today. But if those things aren't there in 2030 or 2040 or 2050 because they're underwater, why are we responding to what's there today with maybe extreme conditions that could be mitigated a totally different way if we have a different environment that we're dealing with? Like, for instance, all of that salt marsh that's behind Black Horse Lane could be underwater with 2.5 feet of grade of sea level rise. So it sort of comes back to a question of what is the state thinking outside the box here relative to allowing designers, your team, to respond as to what we can do that isn't so restrictive, which is more important, a marsh that's going to go away in 10 years or raising the road 4 feet or whatever, whatever the response needs to be for your study going through the next 5 months. Because I see a lot of this stuff changing, and we have millions of dollars of response that are going to be funded theoretically for 2025 or 2026 or whatever. when in 2050, all that stuff is gone and the response could have been completely different. In 25 or 26. I mean, there should be some way for the state to be able to say, we need to give some relief to the environmental regulations if there's a different benefit on the other side, whether it's state funding or whether it's technical issues or community benefits or all of the above.
Yeah.
So
No, I really, I understand what you're saying. I appreciate the logic of what you're explaining. I would say right now, the law and the regulations are what they are.
but they're not being evaluated in terms of.
Well, what I mean is like that, like, if there's an existing resource there, we can't have a negative impact on it. We can't give it a worse chance of surviving, future sea level rise, without mitigating that somehow. But I would say that the state has right now drafted, draft regulatory changes to the wetlands regulations, which is what is related to these different resource areas here. And also chapter 91, which is the tideland regulations, which affects anything that's like a previously filled tideland, like if this used to be underwater and the colonial, let's say in the colonial times, post that time, it was filled with permission from the state, essentially, or otherwise. And also the existing flowed tidelands, which would cover everything that hasn't been filled. So there are draft changes to those that are out for public comment. I think you have until March 1st to submit comments. I suggest that you submit that comment. I think in one of the things that stands out in those proposed regulations that relates to this particular project is they have identified under a specific category of projects called a limited project, a project that would raise a road for resiliency purposes, or relocate one, or remove one. That would affect salt marshes. So that's one thing that it does. So it basically, in a limited project, you are allowed to have some impact. Obviously, the local regulation may be stronger than that, actually. The town of Cohasset may say 0 salt marsh can be impacted, in which case you still have to meet the local regulation. But so the state is trying to provide a degree of flexibility in some specific cases. There are other aspects of the regulations that are going to make it more scrutinized when someone wants to redevelop in a floodplain, particularly in an area that doesn't have already a very high density of development. So it will make it more difficult for people to develop things in risky places, which some people say is a really great thing, and some people won't like it all. And even within the framework of making it, more difficult to do those types of things, there are some allowances for things like this, flood control strategies that would protect areas that are already very developed. So the state's thinking about it a lot. I'm currently the consultant project manager for a plan called the Resilient Coast Plan, where the state is looking for strategies that it can support going forward, strategies that are sort of things it needs to do, but also things that it would that would bring some more coordination, some more consistency to what it's supporting in different communities in different parts of the state. So there's a lot of interest and emphasis on this. I think what the draft regulations that are out there now do some things that could help this project go forward. And that's not where they plan to stop. There's a sort of a 2.0, it's called like 1.0 without anybody having seen a 2.0 or what the scope of the 2.0 is, but to message and to demonstrate that there is something else that's coming that could be different. I think what you're talking about, like really trusting what modeling is showing us to say that these pieces of salt marsh here are gonna be underwater and gone in the future. I don't think that's where they're gonna go, but I get what you're saying, right? Logically, I hear what you're saying. So there's some things going on. There's draft out for public comment. Strongly suggest you submit comments if you have any. Some of the things in there might help this project if they are actually implemented. And yet there could be other longer term changes too. If this project doesn't get built until 2050, maybe the salt marsh is not there at that time and the permitting is very easy, but who knows?
So you have sufficient latitude to run one of your model simulations to remove that and actually make some assessment of what the conditions would be if the coastal bank, for example, or the salt marsh were altered. The salt marsh basically is gone. Rocky intertidal is not going to change. It may be a transition of salt marsh to rocky tidal, intertidal rather. And so I recognize that, yes, you have to work within the regulatory constraints, but that doesn't mean that your model has to be constrained to that necessarily.
Yeah, I would say
So
like very,
how much of a difference? would it make?
if you mean like what's,
It's not going to make much difference in the code, but it could make a significant difference on Black Horse Lane.
you mean like in terms of the protective value that the natural
No,
resources
what I'm
providing?
saying is the
or-
impact of storm surge, perhaps if there were, let's say by 2050 that the salt marsh in along Black Horse Lane had been eroded to the point where it didn't exist anymore. How is that going to change the potential for damage inland? And sort of as a part of that, maybe I'm reaching too far, but we know that the berm at Egypt Beach is, or we suspect that it's vulnerable, and were there that to be eroded and storm surge were to cross over that barrier into Mescatchewan Pond, then you have a whole new scenario based on stormwater flow, storm tide flow down the Gulf River towards Cohasset rather than backdoor scenario.
Yeah,
I know that's outside your geographic boundaries for this particular study, but certainly it has a bearing here. I mean, I think, at least as a natural scientist, I like to look at the system, not the municipal jurisdictions, and to not understand what might happen upstream on the Gulf River leaves us blind.
yeah, so we have done, again, like there's the scope of this project, there's what's the capability of the tools that we have to do
Yeah.
all kinds of different things. Like, so I've worked on a project where in East Beach in Westport. So East Beach is a barrier beach, which means its natural state is to move backwards and be eroded towards land. And it has, backland marshes, etc. But was previously quite developed, now is sort of a seasonal development, but there's an important road that goes along East Beach Road. And it has, like an Irene, got totally washed out. They rebuilt the road. They brought it back a little bit from the shoreline. So it's a barrier beach, so it's sand material. And we looked at these future projections because they were interested in knowing like, oh, what's the possibility of a permanent breach forming through that barrier beach and then creating a new inlet for water, which could change the ecology, which could change the upstream flood risk, et cetera. And, using the best of, standard coastal engineering calculations and tools that are out there, which surprisingly many of them haven't, like the actual fundamental kind of science understanding has not changed since the 80s or even longer than that. Found there was a very low probability that barrier beach, which is south facing, which could be crushed in a hurricane and has been, would form a permanent breach. you know, in the 2050
I mean,
time
there's
horizon.
precedent for that, that the North River opened a new inlet in 1927, I think. Was that when it happened? I may be wrong about that.
Yeah.
Very neat.
1889.
1890s is when the new.
Right, so what I guess what I'm saying is that like, we could evaluate it, we could evaluate that for the Berman Situate, you know. We could also, in our model, which we've done like for the town of Duxbury or for the Duxbury Beach Reservation, we evaluated what happens if this beach wasn't here or was fully eroded? How would that change the risk for, you know, more inland areas of the bay? So we can do those types of analyses and kind of evaluate different scenarios to see, okay, does it make things worse or better? And sometimes the results surprise you.
So my point is, if you're looking at part of the system.
Yeah.
And you're leaving out a significant other part of it, then you, it calls into question that the entire analysis, in my mind. You know, you're ignoring something that yes, it's easy to say, well, it survived a couple of hurricanes or whatever, but if it were to fail, then it would be a very different scenario for Cohasset. Even though it's outside of Cohasset boundaries, it would be a significant event for us.
I mean, I would say that in the storms that we did model, which I showed kind of some of the results in the previous phase, right? Looking at those 3 different or 4 different kind of different colored zones. It's not, you know, the water levels here in Cohasset Cove versus the water levels in here can differ depending on if it's a tropical storm, which is very quick moving, doesn't have time to push water up the Gulf through the inlet, you know, through the mouth of the Gulf, or a nor'easter, which is slower and hangs around a long time. And so the water is able to, but we did model 2 scenarios where water levels were both very high here and here, which was in a nor'easter type event. And because the water levels here and here were about the same in that scenario, again, it was a long-term scenario. I don't know that another opening, you know, miles down in Situate would have made it worse here. You know, so if we're designing for that case, I think it still provides, we can still be confident that it provides that level of protection. Geohazards, you know, notwithstanding, so. Yes.
And I don't mean this as a challenge, and I'm
Sure.
certainly not a scientist, the way Tom is, and things, but I know there's been a lot of emphasis here on surging and you know, draining water out in flood situations, but I'm wondering if there's enough attention being paid, that's not a challenge, to preserving, protecting, and enriching some of the inland marshes. I have bought in Jacobs Meadow, and I've been here for over 50 years, and it's not the same by any stretch of the imagination. When we moved here, there was tidal water that went in and out. It was spongy and had a very different character to it, and I think it acted a bit as a buffer and a sponge. And now the soil is hard, the water comes down, it runs off. There's hardwood growing where we had marsh grass before, and I'm relating to the other areas. I mean, Black Horse Lane, and of course at the end of our Gleason Road across the street there. Maybe we could also take advantage of Mother Nature here and work hard to restore some of these natural buffers. We can't do anything about heavy rainfall, I'm sure, but I'm just not seeing them being as protective. And I use the word buffer. They don't protect it, they don't prevent it, but they soften the flow, and I'm not seeing, Tom, in the marsh itself, any erosion. What I'm seeing is a transformation of soil and ability to absorb rain and so on and so forth.
I would agree with that to some extent, but we do hear from our residents along the Gulf River that they are seeing the salt marsh being eroded, and there's a question of to what degree that's happened.
I wouldn't argue the point, but I think there are some areas of
There are
marsh that
parts
are
of it.
protected that are probably less erosion prone.
Right.
And more might be leveraged to
Yeah, certainly James Brook has
work on our behalf.
is a it's a similar environment, but the amount of open water is pretty different. And on the Gulf where it's wider and you can get a bit of a bit more wind and a bit much more waves and, you know, there has.
I think a different strategy is called.
Yeah. I would just say that I think that the Conservation Commission is cognizant of this, and we are careful to evaluate properties that abut those and encourage people to do everything they can to preserve their shorelines. But your point is well taken. I mean, the natural defenses are really important here.
Invasive. I mean, I've got a lovely Phragmites kind of backyard now that I didn't have 30 or 40 years ago. And it's nobody's fault, you know, it's the evolution and change, but I just think it.
We might be surprised to know that all those rhizomes are pretty hard to erode. And they may be providing more protection.
Well, they may, and as I said,
The cattails or whatever.
I premise that I'm not a scientist, so I will gladly stand corrected, but.
I'm not afraid.
I mean, like, I think, you know, what,
It's tough stuff. Try to remove it and realize just how tough it is.
Oh, yeah.
no, I mean, like what you observe in your backyard that is science, that is data, you know, so I don't want to discount that at all. I don't know the history of, I mean, I know a bit about the history of kind of the change in the management here, the tide gate improvements. I know that the tide gate improvements were intended to provide balance the flood control with the restoration, you know, the ecology of the existing marsh that's there, and avoid negatively impacting people's homes, not necessarily their backyards, but so I know that those things are attempted to be in balance, and what might be good for your property, allowing more salt water in, might not be so good for somebody else's. So the management plan, I think the tide gate management plan was intended to be adjusted if needed based on observations. So I don't know. I hear what you're saying. Agreed, there's a buffering service that nature is providing to us. And we have actually modeled the difference in waves in a different marsh, in Belle Isle Marsh in Boston, where there's a large salt marsh and there's also extensive Phragmites. And we found that like the wave reduction benefits of the Phragmites, not surprisingly, is much greater than the regular, you know, low marsh or high marsh.
That sounds about.
Go ahead.
In this past semester, we have generated a bunch of Cohasset High School students that are particularly interested in salt marshes. So a bunch of them have come down to the marsh at the end of Parker Avenue and done studies to this last semester that they'll be presenting at State of the Harbor. But we now have more of an army of young people who are interested in salt marshes. So if you have specific questions or curiosity or things that you've observed over the years, I always believe that oral histories are like baseline ecology studies. So things that you've noticed that have changed are really of interest, and they're younger, so they don't have that perspective. But definitely tell me if there's a thing that you want us to check out, because we'll probably be looking for more sites this summer to do research on and learn more about our particular salt marshes here.
One of my coworkers is a graduate of the Cohasset Coastal School, so. I think I saw other hands or other people who wanted to make comment or question.
I have a question.
Yes.
The 13-foot, that was on one of the slides, that's 13 feet from mean low.
That's NAVD 88, which is, I think it's basically like sea level, like probably about mean sea level in 1988. I'm guessing is what it sort of probably references.
Okay.
Yeah.
And then,
It's the standard, it's the same vertical datum, like reference point that's shown in your FEMA maps.
okay, and so then we could look at how close we were to those FEMA maps on the 13th of January and get a reference, sort of knowing that January 13th was less flooding than 2018. And then the biggest one I know of was 1635, I think, where Situate Harbor and Cohasset Harbor were in fact connected. Probably where the train tracks are now, so.
Yeah, so I just know from Boston Harbor, because my house is in Boston Harbor. That the water level was around like 8.9, so like say about 9. And then I think it was about like almost 7 in the January 2018 storm. But so it was kind of similar to like the March 2018 water levels. Similar, but it's like, I think it goes something like the one we just had, then the March 2018, and then the January 2018. Again, that's in Boston Harbor.
Yeah,
So-
so part of that is the astronomical and part of it is the surge from offshore.
Yes, yeah. So
And
9,
then if you add
let's say
May
what we just had was
factor
at 9. So 13 is 4 feet higher than what we just had.
Okay.
We've lost a significant local observation of water elevations when that was recorded as notches in a upright post on the old salt house and marked with years. And I don't believe that exists anymore, but
We should start a new one.
well, yeah, start a new one, but we've lost 100 years or more of local observations when that post was removed, or who knows what happened to it. We have a photograph of it, but that doesn't help us survey it in with
Yeah.
modern survey equipment to know what
Yeah.
the elevations actually were in these various storms.
Yeah, I mean, they're for like,
I believe it covered over 100 years of storms
Wow.
on this individual post that was on the part of a structure.
there are like, I think it's USGS reports that are done, for major events where they collect high water marks. So they'll, from photos, from field investigations, they'll say, oh, water was, X number of feet above the stop sign at, this location. And then someone goes out and checks, what is the ground level at that stop sign. And then they make an estimate of what they are. They're not like perfect, right? That's not like a tide gauge that's actually measuring the water level. But some of that data may be recoverable in a way to add back into something like that for the future. Anything else online? How are we doing on time?
It is 8:30.
We're
This
overtime.
always happens.
I
Whenever I hang out with you guys, we just go all night.
I want to see the photo of the post with the notches in it. So if anyone
Yeah,
can
I'll send it to you.
email that, that would be great.
Before we go though, does anybody who didn't speak, does anybody want to say something now, or we can talk afterwards or anything?
thank you.
Oh, thanks.
Yes.
Thank you.
Don't thank me yet. All right. Well, thank you.
Thank you, Robin. We'll touch base tomorrow.
Sounds good. Thanks, everyone.
Hey.
Have a great night.
Have a good night. Thank you.